So this lesson is going to be on circles. We're going to learn how to find the area and circumference of a circle. This may be a review topic for many of us, but it's important that we review it together. So when we start finding area of more complex figures, we're able to utilize this knowledge. So if you're kind of thinking through your head for parts of a circle, I'll start off with the first one. We have this center. The center of the circle is always a point, and it's always labeled by a capital letter if we're looking at a diagram. And then we also, if you remember this, we have a radius. And the radius extends from the center to an edge on the circle, okay? So radius is a segment. And then we end up having two radiuses, and this whole piece is called the diameter. So we have the diameter, and twice the radius gives you the diameter, so 2 times the radius gives you the diameter. Okay, or we could look at half of the diameter can give us the length of the radius. But a diameter has to go through the center. Okay, it has to go through the center. Okay, so now we're going to talk about the area of a circle and circumference of a circle. So many of us probably already know this, but the area of a circle is pi r squared. Okay, where we take our radius, we square it, and then multiply by pi. So at times we can leave our answers in terms of pi, and I'm going to show us what that looks like in a moment. And then the circumference of a circle is 2 pi r, or pi times your diameter. Because we said that twice the radius is your diameter. Okay, so just kind of making sure that you know how to find the area of a circle. So we have our radius is here, and then our diameter is that full piece. So you always need a radius or a diameter to help find the area or the circumference. And the area is the whole, so envision if you had a circular rug, that would be the whole area of a carpet, and their circumference is the perimeter, what goes around the circle. So it's measuring the circumference or the perimeter of the circle. Okay, so we're going to talk first about where pi comes from. And I'm going to have us watch this short video.
Pi. But how do we calculate it? First, we'll draw a perfect circle, and then its diameter. If we take the diameter to equal 1 unit, then measuring the circumference will give us pi. In school, we learned that pi is equal to the circumference over the diameter. So we'll take a look at the circle again.
Over.
And we 3.141.
I'm going to start this over, sorry.
This is pi. But how do we calculate it? First, we'll draw a perfect circle, and then its diameter. If we take the diameter to equal 1 unit, then measuring the circumference will give us pi. In school, we learned that pi is equal to the circumference over the diameter. So we'll take a look at the circle again. And we have a diameter of 1. And measuring the circumference is 3.14159 and so on, which is equal to pi. Now we can take any size circle and measure their circumference diameter ratio. And we see that we always get the constant pi. Regardless of size, pi is going to be the constant of any circle that exists.
So we know pi as 3.14. and it's an approximated number, but we have to, it's also an irrational number, meaning that it never ends, and it comes from the ratio of the circumference to the diameter. So we know how to find the circumference and the area of a circle, but I wanted to explore where they come from. Okay, so let's look and see where the circumference comes from.
First, we'll draw.
Okay. All right.
The circumference of a circle is equal to 2 pi r. But where does the formula come from? First, we'll create a circle and its diameter. Now, pi is defined as the ratio of the circumference over the diameter. Next, we'll look at the diameter, and we can see that it is equal to twice the radius, which simplifies to 2r. And so now pi is equal to the circumference over 2r. Finally, solving for the circumference, we can see that it is equal to 2 pi r.
And then to find the formula for the area, this one's a little bit, this is a longer video, but this is really interesting. So if you wanted to ever go back and watch them again, I have the links, but you can also watch this video. This one's really interesting, so pay attention.
Pi r squared gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So, if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So, how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So
notice how they were using the area of a rectangle to help formulate the area of a circle. So that's a nice visual proof that you can look at. All right, so let's do a few examples. So given a circle with a radius of 11, find the circumference in the area. So first I want you to write down the formulas. Okay, if our radius is 11, we have 2 pi times 11 to find our circumference. So we have our circumference is 22 pi units. So in terms of pi, that means you can just leave your answer with a pi symbol. Okay, so now for this area, if we square the radius, we get 121 pi units squared now, because now we have an area. Let's try two more. So given a circle now with an area of 81 pi, find its radius and circumference. So if its area was 81 pi, what does that mean the radius is equal to? 9. So we had to take the square root of 81 to get the radius. So if the radius is 9, then we know our circumference is 2 pi times the radius, 2 pi r. So our circumference is 18 pi units. Okay. And then lastly, given a circle with a circumference of 18 pi, find its radius and area. So we know the circumference is 2 pi r, and the circumference of this circle is 18 pi. So what we could do here, we could also set up an equation. And if we want to solve for r, that means we have to divide both sides by 2 pi. So remember, pi is a number. So I'm going to reduce that, and then we have 18 over 2, which gives us 9, and then that gives us the radius. And then the area would be pi r squared, so 9 squared times pi, which is 81 pi square units. Okay, so you can always set up an equation to solve. All right, so the last question for the lesson is finding the area of this red region, and we're assuming that the outside shape is a square. So if we're looking at this, we know that the radius of the circle is 3. Okay, the radius of the circle is 3. And can we find the area of the circle? We can. So if the area is pi r squared, we know that the area of the circle is 9 pi. Okay, so we have to find the length of one of the sides, but notice how the 3 is this radius here. But that means if I drew this, that radius is 3, that radius is 3, that radius is 3, that radius is 3. But what if I drew a vertical line here? This radius here is 3, meaning that this whole line altogether is 3 plus 3, which is 6. And isn't that the same length of the square? So we know this is a 6 by 6 square. So if the area of the square is 36, that means the area of the shaded region will be the area of the square minus the area of the circle. And we can leave our answer in terms of pi and make sure you could simplify when you can. However, notice how this 36, we can't subtract 9 pi from it without a calculator, so we'll leave this as 36 minus 9 pi.